Thank you. My name is Aaliyah, and today we're going through Las Ventanas architecture design. My name is Aaliyah. I am the team lead. Ju is our software engineer. Vladimir is also a software engineer along with Marquise, and Catherine is our UX designer.
All right. Los Montanas e-commerce platform. Los Montanas serves as a digital bridge between grocery stores and their customers, offering streamlined inventory management for store employees and a convenient shopping experience for customers. This store platform also facilitates key functions such as product browsing, real-time inventory updates, order management, and a mobile responsive interface. All right. Our design rationale. So, in order to encompass the role of Los Montanas serving as a digital bridge between the grocery stores and their customers for an overall fast, efficient, and convenient streamlined experience, we capture and illustrate the underlying values that led us to this selection. Since COVID 19 in 2021, everyone has been subjected to some form of isolation while being required to limit themselves from the public. That, along with several advancements to modern day technology, which includes augmented reality, machine learning, or artificial intelligence, and increasing accessibility to the internet, led to the emergence of increased e-commerce driven industry. Our website is user based. Whether it be a member, an employee, or a guest, the member and employee requires a username and password, which also has the ability to be multi-factor authenticated. Um, it is aimed to endure all influxes of network traffic and can also be tailored to fit any screen size with optimal performance. Having the ability to shop online 24/7, coupled with secure payment gateways and reliable shipping options, all without the need of communicating directly with the staff, also steered customers towards embracing the online marketplace. In this sense, Los Montanas can scale more rapidly in addition to optimizing operations by automating processes, optimizing inventory management, and gravitating towards data processing for informed decision making. This efficiency enable us to reach more customers, reduce costs, and improve overall performance.
All right, so I'm going to be taking it over from here. Here is the logical view, which we have a composite structure diagram. Here, this diagram illustrates the main components of Las Montana's e-commerce platform and their interactions. This shows the customer interface, which allows the user to browse products and manage their shopping carts, which will connect to the product catalog for product details and availability. The customer can proceed through checkout through the order processing component, which communicates with the payment gateway that handles payment, and the notification services to send order confirmations. The employee interface enables the store employees to manage inventory via inventory management component, ensuring accurate stock levels. This interconnected structure is a, provides a seamless user interface for the customers as well as the employees. Here we have our process view, which is a sequence diagram. Here, this illustrates the customer's journey through Las Montanas e-commerce platform, typically focusing on the shopping experience, which begins with the customer browsing through the website, viewing product details. If they're interested in purchasing, the customer will select Buy Now and is directed to the login or registration page. Once they log in, they can proceed to the shopping cart where their selected products are displayed. We're just going to go through this a little bit faster because I don't want to take up too much time. But once the customer goes through their payments stage, they're going to go ahead and follow through with the payment and through with the checkout process. Once the checkout process is complete, they are able to select the delivery details and finalize their order.
The project is built on layered architecture using the model view controlling pattern. This approach ensures a clear separation of responsibilities among the system components, significantly enhancing modularity, scalability, and maintainability. The first layer is the presentation layer, responsible for user interaction, providing interface for both customers and store employees. The second layer is the business logic layer, where data processing and business rule dictate system behavior. The third layer is the data access layer, which abstracts database operation through repositories. The final layer is the data layer, where data is physically stored in tables and relationship between products, orders, customers, and other key entities. On the next slide, let's move on and explore how the main components are organized and the patterns that ensure the system efficiency. In the presentation layer, interfaces allow customers to browse products and place orders, while employees manage inventory. Controllers handle data related to products and orders. The business logic layer contains core services for catalog management, orders processing, payments, and notifications. The service perform for essential business functions of the system. The use of MVC separate data, logic, and presentation, simplifying components updates. The repository pattern provides data access abstraction, isolating business logic from database operations. Dependency injection ensures flexibility and simplifies testing. Patterns like facade and observe streamline interaction between components and manage notification. On the next slide, let's now discuss the key benefits of the architecture approach. Modularity. System components can be developed and updated independently, making the system more resilient to changes. Scalability. This architecture easily adapts to support new features and increase load. Maintainability. The clear separation of logic across layers simplifies testing and updating the system. In conclusion, the layered architecture provides structure, separation, standardization, data access, and flexibility in components interaction. Next slide, please.
Okay, thank you, Vlad. So there are three main scenarios, and in this case, we'll start off with the normal scenario. And normal scenario isn't just the normal interaction that the customer has when they're on the website. So it starts off with when they browse, and then they add items to the cart. And then once they add that items to cart, it proceeds to checkout. The checkout will then, as you can see from the diagram, it then goes to the Las Montañas website. They verify the products, and then they check for the availability. And once it's been checked, it gets sent back to the customer to get it verified. And then the next key point step is modifications. So again, as you can see from the arrows, they could either say, if they want to add more items again, you go back to the process of adding items to cart. If it's a no, then it continues to the next step with validating the order. And once the order has been validated, then it's confirmed and it moves to make a payment. And then if you make a payment, then you proceed to payment being paid or processed. If not, if you didn't make the payment, you go back to the confirmation step. But once that's done, Las Montañas website will receive the order, and then it will process the payment on their end. Then it'll update the order, and then will send a notification. Then the customer is then notified with the confirmation email that the order has, it's been successfully been processed. That is the normal scenario. Now, if we go to the next slide. So the error scenario. So an example that I used here is a payment failure. So relatively, everything pretty much how it starts off with the customer browsing is the same as a normal scenario until, let's say, once they make the payment and then you go back to where the Las Montañas website receives the order and then is processing the payment. The payment failure occurs if there is any error, and the error could be like anything, if, let's say the credit card was invalidated or didn't accept it, many cases like that. If it gets accepted, then it just proceeds with similar to the normal scenario where accepts the payment, accepts the order, and then just notifies the customer. Now, if there is a payment error, then it's going to reject the payment and then reject the order, and it's going to notify the customer, hey, your order has been rejected. Next scenario. Right, there you go. So special point of variation. So this is basically when there's a deviation in the process, right? And this starts off early. So again, it starts with browse, customer browsing, they add the items, proceed to checkout. But where the deviation occurs here is that it's when it's checking for product availability. If it's not out of stock, then it's going to notify the customers that just like the normal scenario, and hey, it's there, the product's there, proceed as usual. But if it is out of stock, then what's going to do is going to check when the restock date is, and then it's going to create what's called a back order. Basically, it's saying is that hey, the order is the products you have in your cart is not available at this time, but we will update the order and it will process it once it is available. So once that's done, it's going to notify the customer, and then the customer can validate it, and then it goes all the way back to the same process as normal for paid. Once it's been paid, and it's the usual step: orders received, process and paid, updates the order, and then notifies the customer with a confirmation email that the order has been processed. So that's it for the scenarios.
Hi, I'm Catherine, and I'm here for the last maintenance system architecture. So for the systems architecture, it represents the conceptual models, and which is the blueprint for the structure, the behavior, and the views of the system. This is depicted in this presentation using the UML language, which is the Unified Modeling Language. Here I have the class diagrams, the component, and the data schema. These models are then used to design the last maintenance user interfaces. And for these, we have our connectors in this architecture, which are the procedure calls, the event connectors, the data access connectors, and the linkage connectors. Next slide. Here we have the class diagrams for last maintenance class diagrams. And this represents the relationship between the class objects in this diagram. For the class diagrams, we have the representing the static structure of the system. We have the products, the customers, the user, the warehouse, the employee, the order details, the orders, the shopping cart, the shipping info, and the payments. These class diagrams represent the static structure of the last maintenance system and how the objects relate to each other. Next slide, please. Next slide, we have the component diagram. In this component diagram, we have the functional and the non-functional components of the system. And it is depicted in the model view controller architectural pattern for the last maintenance system architecture. So here we can see the product search, the purchase, the registration, which represents the user session. And all these are in the view container. Next, we see the interfaces as they now relate to the controller, and then the model, which stores the database, which houses the inventory component. Then for the users, we have the register, the login, and then we now have the non-functional, which is the authentication process. Then we now have the interfaces that connect these components together, and it depicts our component diagram for last maintenance user diagram. Next slide, please. Here we have the database schema. This represents the entity relationship amongst the different databases in our systems architecture and how they have relationship with each other in our system architecture. Here we have the customer, the products, the warehouse, the employee, the order details, the shopping carts, and the orders. So it shows the entity relationships in our systems architecture. Next slide. Here we have the UI, the user interface. Then all those components and classes were now used to design the last times user interface. Here you can see the search bar on top. You now have the products tabs, you have the order tabs, you have the tracking your order, you have the shopping cart right on top of the menu. Then you now have the arrow keys on the top menu bar. Then you now have the daily promo. Then you have our adverts page that shows our featured products. This depicts our own page, and at the bottom you have the login and the sign up. Then you now have the main categories of our grocery, which are the grocery, the dairy, the household. Then you now have the portion where the user can actually send us a quick feedback about their great experience using our e-commerce website. Next slide, please. Here we have our UI, which presents our sign up and our sign in page. So for those customers that are coming in for the very first time, they have the opportunity to sign up by creating their account. And here they input their details, which are now stored in our database. And the customer becomes registered, and then they can now sign in. And once they sign in, they can now have access to the product page where they can now make their purchase of all the products that they so desire, and they'll have them delivered to them. Thank you.
Alrighty, that concludes our presentation. Thank you for viewing.